Hi, my name is DIVASHIENI. In this video, we're going to explain about cryptology. Okay, introduction to cryptology. Cryptology is the mathematics where we can find in the number theory and algorithms. Cryptology is the studies of secret codes or cipher, and it is a device to create and decipher them. Cryptology is the studies about cryptography and cryptanalysis. The term cryptology is from the Greek. Cryptos means hidden and logos means word. Cryptography is the word from Greek cryptos, and graphein means to write, and cryptography is the studies of technique by which information will be concealed in ciphers and later will be revealed with the secret key. In the simple way, we can say that cryptography is about the secrecy in a written message, and it happens in the wartime. Cryptanalysis is from Greek cryptos, and analysis means to loosen or to unite. Cryptanalysis is the science or art of recovering cryptographically secured information without knowledge of the key. And then next about cryptology application in real life. First is time stamping. It is the device that used to record date and time of day on the document. It is to indicate the document is already received or sent out. And electronic money electronically stores on electronic system and digital database. It is easier to transact electronically, for example like digital cash, digital currency and e-money. And next is about Kerberos. Kerberos is authentication, is currently the default authorization technology used by Microsoft Windows. And implementation of Kerberos exist in Apple OS, FreeBSD, UNIX and Linux. Okay, next about anonymous mailers. It's a kind of mail server that was designed to send email messages without knowing the sender, so you won't know who sent you that message. So next about disencryption. It is the technology that convert to unreadable code that cannot be deciphered easily by unauthorized people. So this is some picture, and this is the time stamping, electronic money, Kerberos, disencryption and anonymous mailers. So that's all from me. Next, my friends will explain more detail. So that's all.
Hi, I hope you have a great day. For my part, I would like to talk about one of the cryptology system, which is Caesar cipher. Caesar cipher, or known as shift cipher or substitution cipher, that given by Julius Caesar, the Roman emperor, who used it in his private correspondence. This famous encryption system involved in replacing each letter of the alphabet shift from 3 positions. How it looks like, I will explain more. But before that, let's take a look on the encryption and decryption algorithm for Caesar cipher. For encryption formula, Y is equal to encryption of A and X equal to X plus A mod M, which is M represent number of letters in alphabet, X represent the numerical equivalent of corresponding letter, or we can say that as plain text, and A is the amount of shift position letter. For the decryption, is the inverse of the encryption formula, X equal to decryption of A and Y equal to A minus Y mod M. That is the Caesar cipher table. The first row of the alphabet represents the plain text, and the second row of the alphabet is the ciphertext, which is this. You can see the position of the letter is shift after 3 positions of the original or plain text. More about example for Caesar cipher will explain by my friends.
Encryption, the process of translating plain text data into something that appears random and meaningless, which is ciphertext. every letter is shifted in front by 3. From the formula, EX equal to X plus shift modulo 26. X refer to the number of letter and shift refer to the number of letter that we shift, which is 3. From the table, A to Z and 0 to 25. Example, encrypt the word magic. From the formula, EX encrypt equal to X plus 3 modulo 26. Encrypt M, 12 plus 3 modulo 26 equal to 15 modulo 26 equal to 15, and from the table we can know that 15 equal to alphabet P. Encrypt also A, G, I, and C, alphabet by alphabet, and we will get the plain text MAGIC to ciphertext PDJLF. Decryption, the process of converting ciphertext back to plain text. Every letter is now shifted backward by 3. The formula, which is dx equal to x minus shift modulo 26, refer to the same thing but in minus sign. We also have the table A to Z and from 0 to 25. Example, decrypt the word PDJLF using the formula dx equal to x minus 3 modulo 26. Decrypt P, 15 minus 3 modulo 26 equal to 12 modulo 26 equal to 12, and from the table we know that 12 equal to M. Decrypt also D, J, L, and F. So the ciphertext, which is PDJLF, and we will get the plain text to MAGIC, magic.
Hi, welcome back. For this part, I would like to talk about another cryptology system, which is AZMAN cipher. AZMAN cipher uses modular arithmetic to perform a calculation on numerical value of a letter to create ciphertext, which is Y. Or we can say that AZMAN cipher is the insecure cipher with additions and multiplication that code another letter with chosen value and relatively prime to modular 26. How about the encryption, decryption formula? Let's take a look. Encryption, we can say that Y is equal to alpha X plus B mod M, which is M number of letter in alphabet, that is 26. X is numerical equivalent of corresponding letter, or we can say as plain text. Alpha X plus beta relatively prime with GCD alpha to beta equal to 1. And the decryption formula, X equal to inverse of alpha multiplication of Y minus beta mod M. For the last from me, I will show you the AZMAN cipher table. As you can see, the first row or the row containing the alphabet is the original letter from the alphabet, or representing the plain text. And the row containing the numerical value, which is 0 until 25, represents ciphertext. There is more example from my another friend explaining about AZMAN cipher. Thank you.
And two examples related to a font cipher, one encrypt and one decrypt. Table 1, numerical value of letter of ciphertext. Example 1, we want to encrypt the message bit using a font cipher with encryption key 3 and 1. Using table 1, represent the message bit with their corresponding number. So B corresponds to 1, E corresponds to 4, A corresponds to 0, C corresponds to 2, H corresponds to 7. Okay, step number 2, Y equal to alpha X plus beta, encryption key alpha and beta. Encryption key 3 and 1, substitute into the equation and we get the equation Y equal to 3X plus 1 mod by 26. Okay, next step, from a table, no, before substitute the corresponding number into the equation y equal to 3x plus 1 mod by 26. Okay, we get the solution. We get the answer y equal to 4 mod 26. So next step, from the table given, replace the number to obtain ciphertext. Okay, the final answer is E, N, B, H, and W. Example 2. To decrypt JRECX with encryption key 7 and 2. So form an equation y equal to alpha x plus beta and change to decryption and inverse of alpha times y minus beta equal to x. So we want to find the inverse of alpha. Inverse of alpha equal to 7 to the power of negative 5, and we can solve to the modulo 26. So alpha times inverse of alpha equal to 1. In same way, inverse of alpha times alpha congruent to 1 mod by 26, and the GCD 7 and 26 equal to 1. By using Euclidean algorithm, solve the Euclidean algorithm until we get the remainder is 1. Extended Euclidean algorithm, solve the extended Euclidean algorithm until we get the final answer is 7 as the main of equation, because we want to find the inverse of 7, which is alpha. Okay, we get 1 equal to 26 times 3 plus 7 times negative 11 mod by incongruence to 1 mod 26. So 26 times 3 plus equal to 78 congruence to 0 mod 26. 7 times negative 11 congruence to 1 mod 26. Let's A equal to NQ plus R. A is negative 11, N is 26, Q negative 1, and R. And we get the answer of R is 15. Inverse of alpha equal to 15. So from the equation x equal to inverse of alpha times y minus beta, we get x equal to 15 times y minus 2. We go from the corresponding value of ciphertext, substitute the value of ciphertext into the equation and get the plain text. And the final answer of plain text is B, R, E, A, and D. So thank you.